energy transfer. Okay, I don't like to call it heat transfer. So you think of energy, you think of heat. But here we go. So this diagram is very typical science class diagram of three different types of energy being transferred here. What you have is A is convection. It's trying to show, there's a flame here. It's trying to show the water in the pot moving. Conduction is if you touch the handle with, in this case, a pot holder hand. And radiation is these given off in the form of waves. So if you stand near a fire and you can like feel the heat coming off, that's usually radiation. So let's get into these. So conduction, physically touching something, direct atom to atom transfer. So I have this hot cup of coffee here, right? And I'm touching it and I feel it to be warm. Okay, so it's transferring heat to my hand. That is direct because I'm touching the mug, which is hot. So that's one example of it. This is actually a diagram from a Regents exam. I don't love it, but this is how they presented it. Where the flame, this is a metal rod. The flame is touching the rod, so there's touching there, and then that causes the atoms in the rod to vibrate faster. It's giving energy to the atoms and vibrate faster, and that's basically what heating something up is. It's the increase in temperature, the atoms in it vibrate faster, which is pretty cool to think about. Which is why something expands. When you heat it up, the atoms hit each other faster and harder, and therefore it transfers more energy. It causes it to expand a little bit. So that's cool. Radiation. The best example is energy from the sun. Sunlight is a form of radiation. Energy in the form of waves. Let's give another example of it is microwave oven. Okay, turn on a microwave. It uses a specific type of electromagnetic energy called microwaves to heat the food, or heat the water in the food, really. But you can't see the waves themselves. They're invisible. And this is on your reference table. Reference table, page 14. If you can see this. Page 14 at the bottom, they have it's this chart, electromagnetic spectrum. Okay, and they show some things here. Okay, so here you go. It shows visible light. I put the colors in there. I like that. It shows violet to red. The visible light spectrum is here. So there's a lot of electromagnetic radiation. Our eyes have evolved to only be able to see this. So you've heard of X-rays. You can't see X-rays through the air. You can't see microwaves. You can't see radio waves in the air. They're there, but our eyes can't detect them. And these are smaller wavelengths, this decreasing wavelength. These are longer wavelengths. So I put them in there to give you a sense. Now these wavelengths is really small, you can't see them, but so they're longer wavelength here, okay, smaller wavelength here, and the smallest are here. So this is all radiation, energy in the form of radiation. Convection is our third type of energy transfer, and in this case it usually it will involve some sort of fluid, something that can move, really a gas or a liquid. So in this case it is a beaker of water. It has a Bunsen burner and they have a colored dye pellet. And basically it asks, so this is going to dissolve and color the water. And how will the water move, or the colored water move? And the answer is like this. It's going to be heated and rise like this, and then move around this way. So this is what convection is. Or it's called a convection current. Let's have some other examples of it. I like this one. This is also showing convection. You have a radiator in the wintertime that heats a room. That basically, it gets really hot, and then the air touches it. The air gets hotter. It will expand because it to be less dense, and that causes it to rise. So the hot air rises and moves along the ceiling. This diagram has a cold window here. So here, the air touching this is cooling. Cold air becomes, cool air is more dense, so then that will sink to the ground, and then it gets pulled back this way, and this is how that heat gets transferred within that room. Here's another example of it. This is another classic science class thing where it's this box here with the candle and a glass front, these glass tubes, and what happens is it heats the air in here, the air rises out this way, and then it pulls in more air here. So this, I believe, was a multiple choice question. How will the air move within this chamber? And it goes, this air will rise here and it goes in this general direction. So this is an example of convection, one that you can often do in a classroom, though it never really works that great for me, but you may have seen it. Hopefully your teacher got it to be able to work really well. Here is, this was a question on a Regents exam, and So I had a Bunsen burner in the middle. It says there's convection currents here. Draw in the arrowheads of how this would be moving. So this is the heat sources right here. So it would look like this, okay? So here you have the hot water moving here, and then it does this. The difficulty here is that this is all stuff you usually can't see. You can't see the water in a pot moving. You can't see the air in a room moving. So that's really the difficult part for convection for a lot of people. So just to review, because this stuff is important, just in general, it's important. Conduction involves touching, physical contact, heat being transferred that way. Convection, movement in a fluid like a liquid or a gas, and caused by density differences. And radiation, energy in the form of waves. Sunlight is a good example. Microwaves are a good example too. So know it.